Welcome to the Boston Echo Board's review course. Today we will be discussing another question of ultrasound physics and ultrasound safety. As usual, there will be a STEM question followed by 4 possible choices. You will have 30 seconds to identify the correct answer and make a choice, after which the correct answer will be identified, followed by a brief didactic discussion regarding the concept presented in that question. Keep an eye on the clock because you have 30 seconds to make a choice, and enjoy. So the correct answer to the question is that increasing pulse repetition frequency increases tissue exposure. Now let's go into the detail of each of these answers and have a didactic discussion regarding tissue exposure to ultrasound. So now we'll be discussing the direct and indirect modes of imaging and how they impact ultrasound intensity. But let's get first to define what intensity is. Intensity is defined as a rate at which ultrasonic energy passes through a unit area, and in this context, we'll discuss all the direct and indirect factors that affect ultrasound intensity during imaging. So let's go to the controls that directly affect intensity. First and foremost is application selection and output intensity. But output intensity is quite intuitive and self-explanatory. We'll discuss the application selection a little bit more in detail. Now, the type of application determines the system presets that are already stored in it. For example, vascular ultrasound, cardiac ultrasound, fetal ultrasound has all presets that have been determined by the manufacturer, that is tightly controlled by the FDA, that have already been determined and uploaded into the system. The Food and Drug Administration regulates the maximum output in the systems. However, there is a user-selected range of intensities that can be adjusted within that minimal or maximal range. So therefore, application selection brings the ultrasonographer to a set of presets which are controlled by the FDA, setting the maximum range of output, and the range of intensities and the outputs within that maximum range can be adjusted by the sonographer. Now let's get to the controls that indirectly affect intensity. They consist of the system mode, pulse repetition frequency, focus depth, pulse length, and transducer choice. For the system mode, it depends on what kind of imaging mode you're using. It could be the B mode, M mode, or Doppler echocardiography. But the more important differentiation that we need to appreciate is that stationary beams lead to a high exposure because of a higher temporal average intensity of ultrasound, because the tissue is exposed for a longer period of time. In contrast, mobile beams or the phased rate transducer, when the beam is scanning from one side of the transducer to the other side, to increase the scan area more than the footprint of the transducer, eventually lead to a lower temporal average intensity of ultrasound and therefore less exposure. Next comes the pulse repetition frequency. So the higher the pulse repetition frequency, technically there would be more output pulses per second. So therefore, a higher pulse repetition frequency increases the temporal average intensity of the ultrasound, leading to an increased exposure with higher pulse repetition frequency. The next one is focus. Focus narrows the ultrasound beam. Now obviously, by concentrating the beam at a very smaller area increases the spatial average intensity of ultrasound. However, most ultrasound systems have presets to automatically reduce the intensity with the use of focus. However, it is important to remember that narrowing the beam raises the intensity at the point of the focal zone. Pulse length. The longer the pulse length, the longer the duration, the greater the temporal average intensity of ultrasound. Longer pulse length is also known to increase the chances of tissue cavitation. And lastly, we get to the transducer choice. Transducer attenuation increases with frequency. Using a high frequency transducer for deeper imaging may require higher output to improve image quality and therefore to reduce attenuation, leading to a higher exposure and higher intensity of the ultrasound. So therefore these factors indirectly determine the exposure of tissues to ultrasound. This was a very important concept, demonstrating the use of our daily controls that we use during clinical ultrasonography can make a significant difference in tissue exposure to ultrasound, increases the patient safety, and leading to a more rational application of the ELARA principle.